Are you ever doing something mundane such as washing the dishes or eating dinner and then you begin to wonder how it will all end? Well, good news if you do, because in a short 3-part series I'm going to go through 3 potential end of the universe scenarios according to science. So how does one approach the end of the universe in a scientific way? Well, one can look at what are known as the Friedmann equations. These equations give us some insight into what 3 potential end of the universe scenarios can look like. The Friedmann equations essentially govern the evolution and expansion of space in homogeneous and isotropic models of the universe within the context of general relativity. What does this mean? Well, homogeneous and isotropic refer to the fact that the universe will look uniform in all directions. And general relativity is simply a physical theory of gravity described as a geometric property of space and time. So today I'll talk about perhaps the most dramatic potential ending of the universe, which is the Big Crunch. The Friedmann equations that explain these scenarios were first derived by Alexander Friedmann in 1922. They were derived from Einstein's field equations of gravitation for the Friedmann-Lemaitre-Robertson-Walker metric and a perfect fluid with a given mass density and pressure. The FLRW metric is a metric based on the exact solution of the Einstein field equations of general relativity. And the metric describes a homogeneous, isotropic, non-static model of the universe, where non-static means it's either expanding or it's contracting. And a metric in this context is simply a way of measuring distances, volumes, and angles in space-time. The idea behind the Big Crunch is that we live in a closed universe, or a universe with spherical geometry, aka a gravitationally bound universe. There are lots of names for the same thing. This universe would have a finite size with no boundary. And in such a universe, and to be honest, all the potential universes I know of, this universe would begin to expand. However, due to gravity, the expansion gradually slows down and stops. Then everything starts going into reverse. The universe begins to contract. Today, when we observe distant galaxies, we see them accelerating away from us. This is due to the expansion of the universe, leading to the light we receive from these galaxies being redshifted. The wavelengths of the light that we receive from these galaxies are longer than they otherwise would be if they weren't accelerating away from us. If we were at the crunch stage of the universe, in this hypothetical Big Crunch scenario, we'd be seeing the opposite. We'd see all the light from these galaxies being blue shifted as they're just accelerating towards us faster and faster. This would lead us to conclude that the universe is shrinking and that it'll all come back to one tiny singular point that we essentially had at the beginning of the universe. Kind of like how we conclude now that the universe is expanding and getting wider because we see all these galaxies moving further and further away from us the further we look. So I think there are a few questions to answer here. First is, how does the geometry of the universe affect its evolution? Are there any alternatives to a Big Crunch? And does this affect our universe? If we look at potential geometries of the universe, we can have a spherical universe, a hyperbolic universe, and a flat universe. Each of these evolving a little bit differently, although the hyperbolic universe and flat universe are pretty similar. For our closed universe scenario, we have a spherical universe, and we can associate the geometry of this universe with the curvature parameter k. For such a scenario, we say it has a positive curvature, where k equals 1, as opposed to k equals 0 or k equals -1. And the future of our universe, given the relativistic Friedmann equation, depends on this curvature parameter k. For k greater than 0, which is our scenario, the density of the universe is high enough that the gravitational attraction will eventually stop the expansion and will collapse backwards to a Big Crunch. This kind of universe is described as being a closed universe, or as I mentioned earlier, a gravitationally bound universe, because everything within the universe is gravitationally bound to such an extent that eventually gravitational attraction will win over the expansion of the universe and bring everything back together. You may have heard of a cyclical universe, one where we have a big bang and then eventually a big crunch where the universe shrinks to a point, then the big bang again, with this process repeating ad infinitum. The idea behind that is essentially that once the universe crunches, it reaches a stage where it's so dense that it begins to expand again. It's an idea that follows on from this Big Crunch idea. As I mentioned earlier, we do have universes with zero or negative curvature, and they evolve in a much more passive way than a universe like this. I should probably quell any fears and say that all evidence we have right now says that we are not heading towards a Big Crunch. Our universe is flat as far as we can tell, and our universe is still expanding at an accelerating rate, so there's nothing to be worried about. Having said that, the fate of our universe would still be quite interesting, so I'll cover the fate of our universe and the hyperbolic universe in 2 future videos, quite soon. So if you like this quick video about how a spherical universe may end, subscribe so you don't miss my video on the hyperbolic and flat universe and any other astrophysics videos that I make. I have links in the description below as per usual, and I guess I'll see you next week for another video about astrophysics.